Okay, now we start with one of the most easiest chapter of standard 10th ICSE maths, that is reflection. Reflection is the most easiest of all the chapters because it is based on the simple fundamental of what will happen when you stand in front of a mirror. So suppose you are standing in front of a mirror and you are going 2 steps behind, automatically the image goes 2 steps behind. If you come 1 step forward, then the image also comes 1 step forward. So we know that the distance between you and the mirror is the same as the distance between the mirror and the image. So that's why the distance is the same whether between you and the mirror and the image, or we can say that between you and the image the distance will be double than what is there between you and the mirror. So this particular kind of questions will be of two kinds. One could be a simple word kind of question wherein you are just going to find out the answer without drawing any graph, or you're just using formula. So one is a formula based exercise and another one is the graphical based exercise. The graphical based exercise is normally the one which is asked in boards or in prelim examinations also. So most of the schools, they will prefer to ask questions in reflection based on the graphical base, but it will be very easier for you to do the graphical thing also when you are knowing about the formulas properly. So we will you have seen that in the Concise textbook, the exercise 12A is the one which is based on the formula based questions, and the exercise B is based on graphical form. So that is how you are having the thing. So let's see what exactly reflection means and what are the different formulas and how are these formulas derived. So let's go about the chapter reflection in detail now. So let's consider first of all that there is one particular graph what we are having, and this graph is in this particular form, which is having the 4 quadrants, quadrant A, 1, 2, 3 and 4. We know over here these are 1, 2, 3, 4. This will be -1, -2, -3, -4. This will be, sorry. This is 1, 2, 3, 4. This is -1, -2, -3, -4. This is -1, this is -2, -3, -4. So this is positive here, negative here, negative here. This is my x-axis, this is the y-axis. So when we have a particular kind of a graph in this form, and suppose I take a point over here which is this way, which is point P is given as 3, 2. Okay. Now if this point 3, 2, if I say that this x-axis, I have placed a mirror over here in place of an x-axis, then what will happen? I can see the image of this particular object at the same distance on this side. So I will be able to get the image somewhere here, that is this particular point. This point over here will be B dash, which will be 3 will remain 3, but 2 will become -2. Got it? So here we have over here that P, when this particular point P, when reflected by the x-axis, the x ka value remains the same, but the y ka value becomes negative. This gives us our first formula, that is P x comma y under reflection of x-axis. We have got at P dash, which will be x comma minus y. Now there is one more thing which we need to know, and that is, if I take this x-axis, the x-axis can also be denoted by the equation, that equation of this line is y is equals to 0. Okay, this x-axis can be represented as, you can say x-axis is represented as y is equals to 0. Why is it so? Because if you see this point, what is this point? This point is nothing but 1, 0. This point is 2, 0. This is 3 comma 0. So every time the value of even this point, this is minus 3 comma 0. So everywhere the value of y is 0. Hence it is y is equal to 0 is the equation of this given line. So this is can be written as x-axis or y is equal to 0. So we say p x comma y will give me the image p dash as x comma minus y under the reflection of x-axis, or I can also say under the reflection of the line y is equal to 0, because y is equal to 0 represents x-axis. We move on now to the next thing, and that is, suppose this point now is reflected through the y-axis. So if this is the y-axis, then what will happen? The distance from here to here, you can see this distance is 3. So 3 over here, that is over here, I will get this particular image as p dash as it will be minus 3 and this will be 2. So it is minus 3, 2. So the image of p 3 comma 2 under reflection of y-axis will be minus 3 comma 2. So here we see that when I am reflecting with my y-axis, my y value doesn't change, but the x value becomes negative. So x value is the interchanging. So we see the next formula as p x comma y under reflection of y is axis. We have p dash which will be minus x comma y. Again, same way, what will happen? Y-axis, this particular point is 0 comma y, 4. This particular point is 0 comma 3. What is this particular point? 0 comma minus 4. So everywhere, what is the value of x? 0. So what will be the representing equation of y-axis? It is x is equal to 0. So we say y-axis represented as x is equal to 0. So we can write over here x is equal to 0. Clear? So we have these particular points over here. So we know over here that if I am reflecting any particular point through x-axis, my x is going to remain intact. Reflection by x-axis, x intact. Y negative. Reflection by y-axis, y intact. X negative. Okay? Just line se wo reflect ho raha hai, that will remain intact. Okay? X-axis se reflection, so x intact. Y-axis se reflection, y intact. The another possibility is that if I place the mirror at the origin, the reflection will be exactly diagonal like this over here. So I am getting the reflection at this particular point. So this point will be p dash minus 3 minus 2. Got it? So this reflection through the origin will be like this. So we can write this formula as p x comma y under reflection of origin will be p dash minus x comma minus y. Got it? So this is how you find out the reflection by the three places of the mirrors: x-axis, y-axis and origin. If it is x-axis, x remains same, y changes. Y-axis, y remains same, x changes. Origin, both changes. What is the change? Positive ka negative, negative ka positive. Okay? It is exactly this way. Now we see something which is called as single transformation. Single transformation is used when I am going to reflect a particular point twice. Suppose I reflect a point, suppose I take a point over here which is like this over here, 4 comma 4. I reflect it first with the x-axis, so it went here. And then I reflected it by the y-axis, so it went here. And if somebody tells me, अरे ये 2 step क्यों लिया? Single step लेना चाहिए था ना? So what would have been the single step? Single step would be directly the origin. Right? So this is the formula for single transformation. What is single? Reflection by x-axis into reflection by y-axis is equal to reflection by origin. Got it? If I reflect it by x-axis, then y-axis, it is actually single transformation directly to origin. Similarly, if I were done this way and I started it reflecting from first y-axis, then I reflected by x-axis. So single transformation will be again origin. So it will be mx into my, my into mx is equals to m origin. The same is also true in other way around. जैसे इसको हम लोग खेल सकते हैं. So like suppose from here the first transformation was the origin. Then I transformed it to x-axis. So the single would be directly from here to here, यानी y-axis. So it will be this way. mo into mx is equals to my. Similarly, mo into my will be mo. These are called as single transformation. You can interchange this. There is not a problem. पहले y लिया फिर o लिया या o लिया y लिया, doesn't matter. Like for example, you can see this one. पहले मैंने x लिया, अभी सबने पहले x लिया. So this one is reflected by x. It went here, and then it went to origin. So it went here. So exactly the same thing. What was the other thing? Origin. Origin के बाद x-axis. So it became this one. See, from here to origin and then x-axis. So it became here. Otherwise, अब उल्टा पहले x-axis फिर origin. तो भी यही point आया. So if I interchange this two, it doesn't make any difference. Interchange this two, it doesn't make any difference. The answer will remain the same. Got it? Sorry, this is x. Okay. So mo into mx will be my. Image from the origin, then by image by the x-axis is nothing but single transformation my. Origin and then y-axis is mx. X then y is origin, y then x is origin. Simple. So that is single transformation. The single transformation questions are normally asked when they tell you that okay, first p is reflected by x-axis, write down p dash. Then p dash is reflected by origin, so write down p dash dash. And then they will ask you what will be the single transformation from P to P dash dash. So this will be the kind of answers you will be writing. Okay, it will be much more clearer to you when we solve the exercise. So that will be much easier. So these are the basic formulas. Now we move on to one more very important formula. Now note that this formula is not given in the textbook. So you need to be very attentive. In fact, when I write this formula over here, I would request you to write that formula on the upper column or any empty space in the textbook itself, as well as I have written over here. You can see I have written it over here directly on that page. तो डायरेक्टली उधर ही लिख दो, चाहिए तो स्टार्टिंग में लिख दो, कहीं भी, बट you write it in the textbook, so it is very handy for you. It should not happen that then you need to look for the textbook or the notebook. अरे यार कौन से notebook में मैंने reflection किया था और कहाँ पे ये लिखा था. Okay, so it's better that you write it directly in the textbook, this particular formula what I am going to give you next. So what is that formula about? I'll just clear this thing so that it's easier for us to understand this part. So we have got this much part. Now, suppose this is the graph. So this is the graph over here. This is 1, 2, 3, 4 x-axis, 1, 2, 3, 4 y-axis, -1 origin, -2, -3, -4 and -1, -2, -3, -4. This is the equation. And I have got a point which is over here, which is this point as P, which is 3, 2. Okay. Now suppose I am placing or there is a line which is like this. Suppose I say that there is a line which is passing like this. It is passing to -1. So now based on this fundamental, if this is y is equals to 0, then because this is passing through minus 1, this equation will be y is equals to minus 1. So you can see y is equals to b is line parallel to x axis passing through point passing through point 0 comma minus 1 on y axis. It is passing through this point 0 comma minus 1 parallel to the x axis. So y is equals to b. This y is equals to minus 1 in this case. It is y is equals to minus 1. Over here, minus b is equal to minus 1. So y is equal to b is a line parallel to x axis passing through a point 0 comma minus 1, that is this particular line on the y axis. Okay. Now suppose I am reflecting this with this as the mirror. So what is going to happen? This is 2 centimeters, then 1, so 3 centimeters. So I go 3 centimeters here, 1, 2, 3. So over here. So this particular reflection from here to here, this will be point P dash will be given as 3 will remain as it is, but this will be minus 4. If this question would have been a graph question, I could have directly done it this way and got the answer without any issues. So no problem at all. But if at all they do not allow you to use the graph and they ask you this question, then what happens? Then you can use a formula over here. So the formula over here when you are having the reflection like this will be, if you are getting that P x comma y reflected by the line y is equals to b. Okay, y is equals to b. Then it will be P. Now you can see P dash. The x was remaining as it is, but this has become 2b minus y. Okay, it is 2b minus y. Let us check out this answer itself. So we see that this was 3 comma 2. So this and this is y is equals to minus 1. So it is nothing but 3 comma 2 into minus 1 minus 2. Okay, that is going to be how much? This is 3 and this is minus 2 and minus 2 is minus 4. So this is exactly the same answer. So that is 2b minus y as the formula. Clear? So this is when the line is parallel to x-axis. Okay, parallel to x-axis. Now the same thing, let's take another one. The line over here is going to be at a point here. Let's take it over here. If this is a line, so this will be represented by what? You can easily identify that this is passing through 1 comma 0. So this, every point over here is 1. So this is x is equals to 1. So what will we write over here? X is equals to A is line parallel to y-axis. Okay, line parallel to y-axis. Passing. What is by passing through? Passing through point. What is that point? 1 comma 0 on x-axis. Okay, this is x is equal to A. So if I got this particular line and it is reflected here, so 1, 2, so it is 1, 2, so the reflection will be here, which will be P, which will be here as minus 1 comma 2. Let's see the formula for this. P x comma y under the reflection of x is equals to A parallel to y-axis, we can say P dash will be 2a minus x comma y. So you can check it out over here. This is 3 comma 2. So this was x is equals to 1. Right? So here we see P dash will be equal to 2 into 1 minus 3 comma 2. So this is nothing but P dash will be equal to 2 minus 1 comma 2. Understood? So this is the formula over here. So that's how you got the formulas for the reflection. So the formulas for reflection are 1. Px comma y under x-axis or y is equal to 0 is Px comma minus y. Px comma y under reflection of y-axis or x is equal to 0 is P dash minus x comma y. Px comma y under origin will be P dash minus x minus y. Single transformation, image of x, image through x, then image through y is nothing but image through origin. Image through y, then image through x is image through origin. Image through origin, then image through x is image through y. Image through x, then image through y will be image through x. Px comma y under reflection of y is equals to b, a line parallel to x-axis, will be p dash x comma 2b minus y. And px comma y under reflection of x is equal to a, line parallel to y-axis is p dash 2a minus x comma y. Understood? So these are the different formulas what you are going to use in this complete chapter. Okay, we do not have anything else other than these in this, and it's very simple. If any particular value is given to you, they will tell you to find out the reflection of this thing. So 5 comma 6 diya hai, reflection x-axis, x remains the same, so 5 comma minus 6. Very easy. Okay, let's start with the exercise now. So this was the detail. I don't think we have missed out anything. Right. Yeah, one more thing. One more important thing is called as invariant point, wherein Px comma y under reflection remains Px comma y. What is invariant point? When a particular point is such that even after reflection the point remains the same. Now you will be thinking that how can it be possible that a reflection even after a point, even after reflection remains the same point? Yeah, it is very well possible. You know how? If the point is on the mirror, then that point will, the reflection of that point will be the same point on the mirror. So those points which after reflection remain the same, they are called as invariant points. So they will be the points which are actually on that particular reflecting surface. For example, if I take the x-axis as the reflecting point, then this point over here, the reflection of P 2, 0 under x-axis will remain 2, 0 only. Y-axis से इधर आएगा, पर x-axis से उधर ही रहेगा. A point over here, which is over here, P is equals to 0, 3. Under reflection of the y-axis, it will remain P 0, 3 only. So that's why this particular point, when reflected by the y-axis, will remain as it is. It is not going to have any change taking place if that particular point is lying on that particular axis or that particular line which is the reflecting surface. So any particular point which is on the reflecting surface, then those points after reflection remain the same. There is no change in the coordinates of this point after reflection. Such kind of points are called as invariant points. Okay, invariant points are points which do not change their coordinates after reflection. So these are invariant points, and yeah, that's it. So we will start with the exercise now. Okay, so it's very easy exercise. We can just go through it fatafat se. Now you can see the first one is the point was 5, minus 7 and its image is minus 5, minus 7. So you can see that both the numbers are changed. So what will the transformation? It will be with the origin. Okay, very easy. Next is 4, 2. I think we can easily go through this thing like this because it's very easy to understand. कहीं पे लगेगा तो we'll write it. Otherwise it can be either verbally discussed. That's why. 4 comma 2 under reflection x-axis, x will remain the same, so it will be 4 comma minus 2. Reflection of y-axis 0 comma 6. 0 comma 6 is there, so it is y-axis. So what is going to be reflection? Y is going to remain the same. So 0 comma 6 agar rahega, so it is on the y-axis. So it will be this way. So it will be 0 comma minus 6. So y-axis will be 0 comma 6. No, sorry, 0 comma 6 is on that line. Okay, 0. It is this way, p x comma y under reflection of y-axis, it is becoming p dash 0 comma 6. You can see the y will always remain the same. You can see over here, y remains the same. So this will remain the same, and this is going to be negative. 0 ka negative 0 hi rehta hai, so it will be p 0 comma 6. So it's an invariant point. You can see this is invariant. Yeah, okay. Next is 6 minus 6 becomes minus 6, 6, origin. 4 minus 8 becomes minus 4 minus 8. Y has not changed, so y-axis. Got it? This is this way. Now you see, we do the alternate sums. Third sum now. Say the coordinates of the following point when reflected by the x-axis. So third one, first is p. So 3 comma 2 under reflection of x-axis will become 3 comma minus 2. Second one, minus 5 4 will become minus 5 minus 4. Third, 0 comma 0 under reflection will remain 0 comma 0 because negative hota hi nahi hai. Fifth one, coordinates from origin minus 2 minus 4 becomes origin say 2 comma 4. Minus 2 7 will become 2 comma minus 7, and origin will become origin itself because for invariant. Question 7. Say the coordinates of the following points when reflected by y is equals to 0. So we are given that y is equals to 0. What is y equal to 0? X-axis. So we have over here minus 3 0. Minus 3 remains the same. So minus 3 0 only. Next is 8 minus 5. So x doesn't change. It will be 8 comma 5. Then you have got minus 1 minus 3. This is going to become minus 1 3. So that's the 7th question. Very easy. We jump to sum number 9. Sum number 9. A point P is reflected by origin, a coordinate of its image R. So they are given that P x comma y under reflection of origin is P dash minus 2 7. So you need to find out the coordinates of P. So P will be 2 comma minus 7. Dono change honge. And second thing is find the coordinate of P under reflection of x-axis. So then this one P under reflection of x-axis will be equal P, that will be P dash, which will be minus 2 x doesn't change, 2 comma 7. Sum number 11. The point x comma y first reflected by the x-axis and then reflected by origin. So P, the P dash has origin to P dash. So we got P, which is x comma y, first reflected by x-axis becomes P x comma minus y, and then reflected by origin it becomes P dash, which is minus x and y. Right, this is what is going to happen. Now see what is given to us. It is given to us that P dash has the origin, has the coordinate minus 8. So this is minus 8 comma 5. So what will be x and y? So you can see over here minus x tha, so x is equals to 8 and y is equals to 5. समझा कैसे किया? They told us that x comma y was reflected by x-axis. So this becomes x comma minus 8. This was reflected by origin. So this has become this much now. Now this value is given to me as this. So what is the value of x? 8. What is the value of y? 5. Right? You can cross check also. This reflected by this over here, it becomes 8 comma minus 5. This reflected by over here will become 8 comma 5. So x is 8 comma y. Right? You can use any method you want. It's very simple. It doesn't require any kind of a method to show. It's direct answer to be written. So you can use any method you want. Sum number 13. The point 4 comma 6 is first reflected by the origin to A dash, and then A dash is reflected y-axis to A dash dash. So A is 4 comma 6 reflected to the origin, so it becomes A dash, which is minus 4 minus 6, and then it is reflected by y-axis, so it will be A dash dash, which will be y will remain same, so 4 comma minus 6. You need to write the coordinates of A dash dash, so A dash dash is 4 comma minus 6, and you get single transformation from A to A dash dash. From A to A dash dash, what is the single transformation? Origin into y. You can see origin into y is x, so it is single transformation is equals to x-axis. Okay, so x-axis, or you can say mx. Single transformation is x. You can directly write as single transformation as x, or you can write over here as reflection in x-axis. You can say a single transformation reflection in x-axis. So sum number 13. We move on to sum number 15 and 17. Two more. We'll finish this thing. P and Q are coordinates this and this respectively. So P is the 15 sum. P is minus 2, 3, and Q is 5, 4. P is referred to x-axis to P dash, and Q is y-axis for Q dash. So it's very simple. P minus 2, 3 under x-axis with P dash with 2, there will be minus 2, minus 3. Q is 5, 4 under reflection of y-axis is Q dash, which is minus 5, 4. Okay, that's the answer. Question number 17 is A is 4, minus 1 reflected as A dash in y-axis. So y-axis A dash will be, y remains same, so minus 4 minus 1. Point B on reflected in x-axis is mapped to, so B, which is x, y, is reflected by the x-axis and mapped to B dash, which is minus 2, 5. So this will become, x doesn't change, so minus 2, minus 5. So B is minus 2, minus 5. That's the answer. So this was the first exercise. You can see it was hardly 5 minutes job. So no doubt the explanation was in detail, so it took time, but otherwise the chapter is absolutely very easy. We'll take up the next video for the sums on graphical method. Okay.